Blood donation facilities seek to maximize collected donations while minimizing the collection cost. It's therefore important for these facilities to predict the number of donors so they can efficiently plan a blood collection event. The purpose of this assignment was to evaluate past donation patterns to determine whether we could predict attendees at future blood collection events. The dataset used was from the UCI Machine Learning Repository and contained 576 observations. There were no missing observations, and it included 6 variables: the donor number, the number of months since the first donation, the total number of past donations, the total volume of blood collected in the past, and the number of months since the most recent donation, and a flag variable indicating whether the donor made a donation at a March 2007 event. A scatterplots matrix of these variables showed that they were heavily skewed, and there was perfect correlation between the number of donations and the total volume donated. These two variables were essentially measuring the same thing, since the volume of blood donated at each event is constant, therefore meaning these were perfectly collinear variables. Transforming these variables to help normalize the data shows that it really was not that effective. We tried capping the variables, doing a Box-Cox transformation, as well as standardizing the variables, and while it improved the normal distribution, it didn't completely solve it. A literature review included the Box-Cox article from 1964 regarding the exponential transformation of variables. And then a number of flag or dummy variables were created for this assignment based on findings from a number of research papers. These included a research paper from O&B that found that the probability of donating was inversely related to the number of past donations, as well as finding that the probability of donating is proportional to the average return time between donations, as can be seen from these charts in this table. And James and Matthews in 1993 found that the probability of donating was inversely related to the time between just the first and the second donation. As a result, a flag variable was created to measure this in our current data set. 3 years later, James and Matthews found that the probability of donating was inversely related to the time since the last donation, not surprisingly. What they did find was that, in particular, 52 weeks after the last donation, the probability of someone donating again dropped off significantly. We found similar breaks in this data set and therefore created dummy variables to measure that. And finally, Yang and Ting in 2009 used a recency, frequency, and monetary value model, basically assigning values to certain observations and assigning a score to this, and then adding up that score and using that as a predictor variable. So created a variable in this data set to measure that as well. The models were formulated using R, prepared a training set with 80% of the data and a test set, so we could test the models internally on this data set. Used a binomial logistic regression because the dependent variable was either a 1 or a 0. So binomial logistic was used for all of the models. 6 models were used. A controller-based model used only the original variables discussed above, and then the other 5 models used the dummy or indicator variables discussed from some of the papers, as well as transformation of the variables, including a Box-Cox transformation, a standardized transformation, a standardized version of the Box-Cox variables, capped continuous variables, and then finally a full model, which was selected from all of the transformed variables to see if any of them were selected. The write-up and the next slide only shows 4 of these models, which are asterisks on this slide. So you can see the performance of these, in particular the full model, which used the indicator variables for donations, 1 previous donation, 2 previous donations, and 3 previous donations, basically penalizing the probability. That was the selected model, and it was the one identified in driven data as the best. So the learnings included factoring continuous variables, in this case, proved to be pretty helpful. However, I've done some reading and I found that it generally leads to less precision, and so future work could use regression splines. There's a limited number of variables in the data set, and the publications that I read used more demographic information to accurately predict the return donors, and so therefore future work would try to incorporate age, gender, income, that type of thing to help more accurately predict, as well as future work could include a longitudinal study to measure individual donation patterns for these particular donation subjects.